The topic is gases and liquids. Let's do some objective questions on gases and liquids, that is gaseous state and liquid state. Let's start with question number 1. The question is, for a given mass of a gas, if both pressure and absolute temperature are doubled, final volume will be. You are doubling pressure and you are doubling absolute temperature. Let's see the options. First option, decreases to half of initial value. 2, the initial volume is doubled. 3, remains unchanged. And 4, becomes 4 times of initial value. See, volume of gas is directly proportional to absolute temperature. If you double temperature, volume will be doubled. And volume is inversely proportional to pressure. That means if you double the pressure, volume becomes half. So what we are doing here is we are doubling pressure as well as temperature. We are doubling this as well as this, so volume does not change. So the answer is third option. Volume remains unchanged. Question number 2. A gas at STP occupies V liters. If its temperature is increased to 546 Kelvin and pressure is decreased to 380 millimeter of mercury, the resultant volume would be. Now, we know that volume is directly proportional to temperature and volume is inversely proportional to pressure. At STP conditions are temperature is 273 Kelvin and pressure is 760 mm. These are STP conditions. Now what you have done is you have doubled the temperature. This is T1 and P1. Now T2 is you made it 546 and P2 you have halved it 380 mm. So due to doubling of temperature, volume doubles, and due to decreasing the pressure to half, volume again doubles. So the net change is volume becomes 4V. It increases 4 times. So the correct answer is second option, 4V, doubling due to this. So overall increase in volume is 4V. The answer is second option. Question number 3. Find the pressure of 16 grams of O2 gas in atmospheres present in a flask of 1.12 liters at 0 degrees Celsius. So weight of oxygen is given as 16 grams. Its gram molecular mass is 32. So number of moles comes to 0.5, 16 by 32. From this you get this. Now R value you take it as 0.0821. T is given as 273 Kelvin. 0 degrees Celsius is 273 Kelvin and volume is given as 1.12 liters. Now you are asked to find out pressure. So you can use this formula, PV equals to nRT. N can be replaced by weight by gram molar mass. So this is the formula you are going to use. Now P equals to weight is 16 by 32 into 0.0821 into 273. This is divided by, we need volume also, it comes to 1.12 liters. So if you cancel out the values, the answer you get is 10 atmospheres. Question number 4. In a mixture of equal weights of H2 and He gases at pressure of 6 atmospheres, the partial pressure of helium is. First option 3 atmospheres, second option 4 atmospheres, third option 2 atmospheres, and fourth option is 6 atmospheres. Let's try to calculate. You have equal weights of H2 and He gases. Let's assume that the weight of gases is W. So number of moles of H2 is W by 2 and number of moles of helium is W by 4. And then the total pressure P total equals to 6 atmospheres. Now, according to Dalton's law, partial pressure of say helium is equal to into total pressure, that is 6 atmospheres. So to find out mole fraction of helium, we need to use this W by 4 divided by W by 2 plus W by 4. This will give mole fraction of helium, and this multiplied with 6 will give you partial pressure of helium, and the answer you get is 2 atmospheres. So obviously partial pressure of hydrogen will be 4 atmospheres. Question number 5. 2 flasks of 10 liter each contain the same weights of N2 and O2 gases at same temperature. The ratio of pressure of N2 to the pressure of O2 in the flask is given by first option 7:8, second option 7:16, third option 8:7, and fourth option is 1:1. You have same weights of N2 and O2. So number of moles of N2 equals to W by 28, and number of moles of O2 will be W by 32. So you have more moles of nitrogen, and the ratio will be 32:28, which comes to 8:7. So the correct answer is third option, 8:7. Question number 6. 2 grams of a gas X exerts the same pressure as that exerted by 8 grams of SO2 in the same flask at a given temperature. Molecular weight of gas X is. See, 8 grams SO2, you can say number of moles of SO2 will be 8 by 64. This comes to 1 by 8. Because the pressure exerted is same, then the gas X, number of moles of X also should be equal to 1 by 8. So you can say 2 by molecular weight equals to 1 by 8. So molecular weight will be 16. So the correct answer is second option, 16. Question number 7. A gas X diffuses 3 times faster than water vapor under similar conditions of pressure and temperature. Molecular mass of gas X is. This question is based on Graham's law of diffusion, and it says that the gas X is diffusing 3 times faster than water vapor, 3 times faster. That means it must be a lighter gas than water. Its molecular mass should be less than 18. Let's try to calculate. See, rate of diffusion of X by rate of diffusion of water is equal to root 18 by m, where m stands for molecular mass of the unknown gas. Now this will make it, this is 3 times faster, so 3 equals to root over 18 by m. Now you square both sides, then this becomes 9 equals to 18 by m. So m equals to 18 by 9, that comes to 2. The gas could be hydrogen gas because its molecular weight coming to 2 units. Answer is second option. Question number 8. Which of the gases among O2, CO2 and SO2 under similar conditions diffuses slower than N2? See, molecular mass of N2 is 28. Molecular mass of O2 is 32. Molecular mass of CO2 is 44. Molecular mass of SO2 is 64. You can see all of them are heavier than nitrogen. These are all heavier than N2. So they all diffuse slower than N2. So the correct answer is fourth option. All the 3 gases O2, CO2 and SO2 diffuse slower than N2. Question number 9. RMS velocity of carbon dioxide gas at 167 degrees Celsius in meters per second is close to. See, RMS velocity stands for root mean square velocity. It is given by the formula C equals to root over 3 RT by M, where R is gas constant, T is absolute temperature, and M is gram molar mass. So if you put the values, C equals to root over 8.314 into 440, because the temperature mentioned is 167 degrees Celsius. You need to add 273, you get Kelvin temperature, divided by 44. This comes to, if you simplify this comes to 15.8 meters per second. This comes to very close to 25. This goes 10 times. Root over 250 is very close to 15.8 meters per second. Question number 10. RMS speed of oxygen molecule and that of hydrogen molecule at a given temperature are in the ratio of. See here, there are two gases, oxygen and hydrogen, both are being maintained at same temperature. You are asked to compare their RMS velocities. This is the formula. C is equal to root over 3 RT by M. This is the formula used to calculate RMS velocity. When you are comparing, you can say CO2 and CH2, RMS velocity of oxygen to the RMS velocity of hydrogen. This is equal to root over MH2 by MO2, where M stands for molecular mass. So CO2 by CH2 comes to 2 by 32. This goes 16 times and root of 16 is 4. So CO2 by CH2 comes to 1 by 4. So the correct answer is third option. Question number 11. RMS speed of SO2 molecule at 400 Kelvin is equal to RMS speed of methane molecule at what temperature? C equals to root over 3 RT by M. Now what you are asked is C SO2 is equal to C methane. You are asked to find out at what temperature this can happen. When SO2 is at 400 Kelvin, what should be the temperature of methane at which these two will have same RMS speed? So root over 3 RT SO2 by 64 is equal to root over 3 RT methane by 16. The roots get cancelled, 3R also will get cancelled. So you can say TSO2 is given as 400. So 400 by 64, this is equal to T methane by 16. So this goes 4 times. So T methane equals to 100 Kelvin. So the correct answer is third option, 100 Kelvin. Question number 12. Find the kinetic energy in kilojoules of 2 moles of an ideal gas at 2000 Kelvin. R value is given as 8.314 joules per Kelvin per mole. Let's find out. K is given as K equals to 3 by 2 nRT. So what is the data given? Moles is 2. So 3 by 2 into 2. You want the value in kilojoules, so take R value as 8.314 into 10 raised to minus 3. And the temperature given is 2000 Kelvin. And on simplification, the value you get is 50. So the correct answer is second option. Question number 13. Kinetic energies of 4 grams of SO2 gas and that of 1 gram of methane gas at a given temperature are in the ratio. Let me put the formula. Ke equals to 3 by 2 nRT. Now, Ke of SO2 is equal to 3 by 2 into 4 by 64 RT. And then K of methane 3 by 2 into 1 by 16 into RT. So if you cancel off this, 4 1s are 4 6 are So you can see they are 1:1. So the correct answer is fourth option, they are in 1:1 ratio. Question number 14. Which of the following statements is contrary to postulate of kinetic theory of gases? That means which of these statements is not a postulate of kinetic theory of gases? Look at the options. Number 1, all the molecules of gas are in random motion. This is true. All the molecules of gas are in random motion only. There are no forces of attraction or repulsion among molecules. This is also as per kinetic theory of gases. After each collision, the total kinetic energy of gas gradually decreases. It's not true. There's a conservation of kinetic energy. So let's look at the fourth option also. At any particular time, different particles in the gas have different kinetic energies. So this is true. So the correct answer is third option. Third option is an incorrect statement. After each collision, the total kinetic energy of gas gradually decreases. This is not a postulate of kinetic theory of gases. The correct answer is option 3. Question number 15. Deviation of real gases from ideal behavior is highest at which of the following conditions? First option, high pressures and high temperatures. Second option, low pressures and low temperatures. Third option, low pressure and high temperature. Fourth option is high pressure and low temperature. The correct answer is high pressure and low temperature, because if the pressure is high, then the volume occupied by gas molecules will be considerable when compared to the volume of the container. Because at high pressure, the volume occupied by gas will be less and the volume occupied by gas molecules becomes important. And then because at low temperature, the molecules are moving slowly, they can attract each other more strongly and can cause more deviation. So the correct answer is fourth option.